Here I'm going to go through how to name organic compounds, and I'm going to go through the series of functional groups for naming that are in the IB Chemistry HL curriculum. So we're going to start with just basic alkanes. An alkane is going to be only single bonds, no functional groups except for maybe a halogen. And the rules for naming alkanes, you start by numbering the longest chain possible. And then whatever that longest chain, however many carbons there are, you're going to use the prefix for that number of carbons followed by A and E. And then you're going to put your side chains, and that's going to be however long the side chain is, followed by YL. So a methyl group would be 1 carbon as a side chain, and an ethyl group would be 2 carbons. If you have numbers where you have multiple numbers in a row, you're going to separate those with a comma. If you have a number next to a letter, you're going to put a dash in between. And you are going to list the side chains alphabetically. Use di or tri prefixes. That does not affect your alphabet. So ethyl would get listed before methyl, which would get listed before propyl. Okay? So what I want to do for each of these is go through just a simple example and then a little more complicated example to kind of give you an idea. So for our simple example, we're going to have 1, 2, 3, 4, 5, 6. If you're unfamiliar with the shorthand for this, every point on here is a carbon, and it is saturated with hydrogen, so carbon normally forms 4 bonds. So this particular carbon here has 1 bond to another carbon, so it must have 3 hydrogens. This carbon here has 2 carbons bonded, it must have 2 hydrogens. This carbon has 3 carbons connected to it, so it must have 1 hydrogen, so on and so forth. So this is C6H14 when you add it all up. And the name of this, what I would do is I would number it 1, 2, 3, 4, 5. I want to do my numbering to minimize the number on the side chain. Now if I did this in the other order, it would have been this exact same thing. So it doesn't matter which way I do this particular one. So the way I would name it is I would say that this is 3-methyl pentane. And I'm getting the pentane from the fact that I have 5 carbons in a row. When I say the longest chain, I of course mean how many carbons you can trace without picking up your finger. Okay. And then the location of the side group, the branch here, is the 3rd carbon, and it's 1 carbon attached, so therefore it is a methyl group. And a more complicated example of this. Okay, so this is a lot of carbons, so I'm actually going to switch color here. That's a little distinct. So it looks to me like the chain is longest along this path, and this is supposed to be connected here. So there's 2 ways to number this. We can name 1, 2, 3, 4, 5, 6, 7, 8, 9, or we can go the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to analyze this from the perspective of minimizing the numbers. And in this case, you have 3 side chains. So they can either be at 4, 5, and 7, or they can be at 3, 5, and 6. You will choose whichever one minimizes the first number. So the first smallest number possible is the 3. So I'm going to use this numbering system here along the top rather than the one that I have along the bottom. Okay. I have 9 carbons, so I'm going to have 9. So prefix for 9 followed by A and E. I have 2 different types of side chains. I have a methyl here. I have an ethyl here at the 5, and I have an ethyl at the 6. Now I'm going to list the ethyl groups first because they're alphabetically first. So I'm going to write 5, 6 diethyl, and then I have a methyl group. Give myself a little more space here. So 3-methyl nonene. So 5,6 diethyl 3-methyl nonene would be the name of this particular alkene. Okay. Now if you have halogens to add in, you treat them just the same as a methyl and ethyl propyl group. For fluorines, you would use the fluoro designation. Chlorine would be chloro. Bromine would be bromo, and iodine would be iodo. Okay, so that's your basic naming for alkenes. So for an alkene, we're looking at something with a double bond present. Okay, and for that we have a couple new rules to add on to our previous ones. The chain must include the double bond if that's the only functional group present. And the location of the first carbon is going to be what you use in that double bond to figure out how to kind of name where that is. So I'll show you that in an example. And the last thing that comes up with alkenes is that there is a stereoisomer presence here, diastereomers, where you can have two different forms of that, either the E or the Z kind, or the cis or the trans label might go on these. So let me show you a couple that we can kind of go through those rules. So a simple example, here we have C4H8, okay? So numbering wise, 1, 2, 3, 4, doesn't matter if we go in the reverse order, it's symmetric with respect to that. So we're looking at but for our prefix. And then instead of butane, because it has a double bond, we're going to put E and E. And we're going to put the number 2 in between, because the number 2 is the first location of that particular double bond. So you put the first carbon in your numbering scheme that's attached to the double bond as a number present in between the prefix and the ene suffix. Okay? So in addition to that, there are two ways to have butene. You can have it as I've drawn up there. The other way is like this. And those are actually structurally different from each other in some ways. And so therefore we would characterize this. Now the one where the two methyl groups of the chain are on opposite sides of the double bond, or I'm sorry, they're on the same side, we would characterize that with a Z, or you could also characterize that with a cis. Z is for Zusammen, it's a German word that means the same. For this one, you would use the E designation or the trans. Okay, so let's go ahead and look at a more complicated example. So let's see. Okay, so that looks a little more fearsome. So what we have going on here is we have the double bond here. We need our chain to include that. Let's see, we can do two numbering systems. We can do 1, 2, 3, 4, 5, 6, 7, 8. Or we could do 1, 2, 3, 4, 5, 6, 7, 8. We want the numbering system to minimize the double bond in this case, so we're going to go with the black numbering system that puts a 3 here instead of a 5 in the reverse direction. Okay, we have 8 things, so we're going to end up with oct 3E as our base. And now we need to do our side groups. Okay, so we're going with the black numbering. We have a methyl group at 5 and a methyl group at 3. So we're going to have a 3,5 dimethyl, oct 3E. Okay, and that would be our name. Now, in addition to that, we do have the case where we have potential for different things on different sides of the double bond. And this one's a little trickier than the last one. This one, you had a CH3, a CH3, an H, and an H. This one, we have a hydrogen here, and a large group over here, a methyl group, and then an ethyl group over here. These aren't really methyl and ethyl groups. This is how I'm describing them. So what we do for that is we use atomic number to assign priority. So a carbon attached here has atomic number of 6. Atomic number of 6, that's a tie. But if we continue out, we get another atomic number of 6. This has the higher priority. And then this one, we have a hydrogen, atomic number 1, and a carbon. So this has the higher priority. So you can see that they're on opposite sides of the double bond at a diagonal from one another. And so then we're looking at the E designation. So this would be E35 dimethyl oct 3E. So for alkynes, we're looking at a triple bond present now. No really new big rules that are different from anything in the past. We're just going to use the designation of having a YNE instead of an ANE or an ENE. So let's look at a simple example and then a complicated example. So here we have a set of carbons. 1, 2, 3, 4, 5, 6. If we did this numbering backwards, we would end up with a larger number of the triple bond, so we're going to avoid that. So we're looking at hex 2 ine. And then we have a methyl group at the 5th carbon, so this would be 5 methyl hex 2 ine. And for a little more complicated example, take a look at this. And for our numbering, we would go 1, 2, 3, 4, 5, 6, 7, 8. We're going to do it that way because that's going to minimize the first number on our triple bond. Otherwise, we'd be 1, 2, 3. Here we're at number 1. Okay, so this is just 8 in a row. So we're looking at octyne, but we have 2 triple bonds. So we're going to write oct 1, 5 di-ine. Okay, so the di tells you that there are 2 triple bonds, one located at the first carbon, one at the fifth, and there are 8 total carbons in that particular chain. Okay, now from here, we're really not adding a lot of new rules as we go, but now we're going to start to go through the different functional groups. So for the class of alcohols, we have a hydroxyl group present. You're going to change E at the end of the thing to OL. And then you're going to put a number of where that alcohol, the hydroxyl functional group, is present. Okay, so looks like I've put up the complicated one first. So we'll leave that up there for a second. Let's go ahead and do the simple one first. All right, so in this one we have 1, 2, 3, 4 carbons. So we're looking at butane. When we get to the E, we're going to change it to OL, and we're going to put what number that is present. So butanol. Now, I'm going to point out, there are many ways to write this. A lot of people write this as 2-butanol or a more common name of this. I'm doing the IUPAC naming system with a kind of a rigidity to it because that's how the IB is going to present it, and so I'm going to do all of my naming systems is strictly in IUPAC exact form. There are other names that are acceptable for this, but this is the way that I'm going to be doing this. Okay. Now on the other one, we're going to start numbering on this side. This is my first carbon. This attaches just to the oxygen here. 2, 3, 4, 5, 6, 7. So I'm looking at 7 carbons, so I'm looking at the prefix of het. I have no double or triple bonds, and I have 2 of these. So I'm going to go 1, 2, diol. And then I have a chloro group and a methyl group. Chloro comes first alphabetically, so I'm going to put 4 chloro, 5 methyl, heptane 1, 2 diol. For ethers, you're going to take the simpler chain, which might be a tie in some case, as a side group. And you're going to use an oxy suffix. Okay, so this one's a little more complicated. Let's look at a simple example here. Okay, so here's our ether. It's got a carbon group on both sides. We have 1 over here, and then we've got 1, 2, 3 over here. Not sure how to make this number. Now, our simpler side is this. So that's a methyl group, and here we have a propane. So what we would call this is we would call this methoxy, where we change the methyl part to oxy suffix, and then methoxypropane. There are a lot of other common ways to name ether that are a little simpler than this, perhaps. This is the actual IUPAC way to do it, so that's what I'm going to go for. Let's look at a little more complicated one. Keep in mind that in IB we're limited to 6 total carbons for the functional groups. So my simpler side chain is here. That's an ethoxy group, and it's attached at the second carbon of butane. So this would be 2-ethoxy butane. And just to make that clear, what I'm saying there is I have 1, 2, 3, 4. Here's my butane, and then I have an ethoxy group attached at the second carbon. Okay. For ketones, ketones, you're going to change the E at the end to an O and E, and you're going to number where that carbonyl group is present. Okay? So simple example, 1, 2, 3, 4, 5. Okay, so here we have 1, 2, 3, 4, 5, 6. So we have this group here, the third one. Otherwise, it's just a hexane, so this would be hexane. We lose the E, we change it to O-N-E. Hexane 3O would be the name of that one. A little more complicated one. Okay, so this one doesn't matter which way you name it. It's symmetrical with respect to numbering. We have 3,5 or 3,5. It's 7 carbons, so we have hept, and then we have a 3 and a 5 ketone, so 3,5 dione. So heptane 3,5 dione would be the name of this particular one. For an aldehyde, you're going to change E to Al. You do not need to number because an aldehyde has to be terminal. So our simple example would just be this. Now there's a hydrogen here, part of the functional group for the aldehyde functional group. Other than that, I have 2 carbons. This would be F, anol. That would be it. For a little more complicated one here, we can do okay. So 1, 2, 3, 4, 5. So this is pentanol, but we have a methyl at the third carbon. 3-methylpentanol. Okay, so in ester we're going to have a particular R group, which could be anything, then a carbonyl group, then an oxygen, then a second, a potentially different R group, which could be anything. So the way to name these is you name R2 first as its own thing. Okay, and then you're going to name R1 with the E on it changed to OE. Okay, so if we're looking at the first example here, we're going to name R2 first, which is a methyl. Okay, and then so we have our 1 carbon here, and then we have our 2 carbons here, and so this is going to be an ethanoate. So the name of this particular ester would be methyl ethanoate. Okay. On the second one, we have 2 carbons here, so we have an ethyl. And then we have 1, 2, 3 carbons here, so this would be ethyl propanoate. Okay. And that would be what you would do for esters. Okay, so for carboxylic acid, we have our carbonyl group, but there's a hydroxyl group adjacent to this. It actually combines to form our carboxyl group. It's really not a carbonyl or a hydroxyl group. For naming purposes, you're just going to, just like always, you're going to number your chain. You can start your numbering over closest to the functional group. And we have butane here, but with a carboxylic acid. So instead of butane, we would write butane, and we would change the E to OIC acid. So this would be butanoic acid, right? And then this one over here, we have our first carbons, second, third, fourth, and fifth. So we're looking at pentanoic acid as our base. And the pentanoic acid has a methyl group on the second carbon, so this would be 2-methyl pentanoic acid. So if you want to go through and click on the website, there's a link to some notes on this organic naming process, all from the IUPAC perspective. And at the end, it gives a summary of all the naming endings. So if you have a functional group that's a halogen, do you need a number label? How do you change the ending? For halogens, you don't. For an alkene, you need to label where the double bond is present, change A and E to E and E. An alkyne, you change A and E to Y and E. Alcohol, you change the E, regardless of which one it is, to an OL. An aldehyde, you change the E to an AL. A ketone, the E is changed to an ONE. And the ether, you go through and do the whole methoxyethane process. For an ester, you're changing the methyl propanoate or whatever it is. And the carboxylic acid, you're changing the E to the oic acid. And then it also indicates whether you need to number. For an aldehyde, for a carboxylic acid, an ether, or an ester, you don't need to do that because you're either at the terminal carbon or you're in a situation where you're naming both of these substituents. Okay? So all of those details are present there. Kind of give you an overview of the entire naming process for all of those functional